So for my organism, we're going to be focusing on my creature called a Tashigo, which has a lot of different traits that we can focus on, but for today we're going to be focusing on tail type, color type, and feet type. So for our parental types, we are going to be looking at a snake tail color and hands for feet Tashigo with a cross with a squirrel tail, black and white, and feet for feet Tashigo. And from that, we are going to get a heterozygous individual, which we will cross with a homozygous individual. The reason that we cross our F1 generation with a homozygous recessive individual is to act as the test cross, so we can see our phenotypes just based on the genotypes of the gametes. We are able to determine that A is at the first gene loci because it has a smaller chance of recombination and based on our calculations. And so in other words, there's less positions for it to separate from the rest of the chromosome, which is why it would be at the smaller distance rather than the larger one. From our calculations, we were able to determine that the probability of a specific gamete from a DCO event was going to be about 3.456%, while a single crossover event at loci 1 was going to be about 26.5%. We were able to determine these percentages based on the probability equation that we can use for a DCO and a SCO1 event. And so here you can see R1, R2 times C. C is going to be 0.64, and with 6 centimorgans, we're going to use 0.06 in our calculations. 18 centimorgans, we're going to use 0.18 in our calculations to get 0.006912 for our DCO event. And for our single crossover event at loci 1, it's going to be R1 minus the DCO event, which is how we get 0.053088. So based on finding our crossovers and what our gametes are going to look like, and calculating what the probability of them occurring, we were able to map out what genes are at each loci.